Hello folks, welcome back. Today we've got an informal project. This is a Series 2 International Time Recording master clock, and this is a clock that is weight driven with a motor rewind. You can see the movement here. It looks very much like other master clocks we've worked on. The difference is this little motor up here. This is an AC motor that runs on 120 volts. We can see these two pulleys. Those run to the weights that are below the camera here. Both of these lines attach to this winding drum right here, and that's what powers the movement. The way this clock is supposed to operate is when it's fully wound, the weights come up to these screws, and then the clock runs for about 30 hours, and then that triggers via this switch right here, an automatic rewind, so the clock runs with the weights moving up and down just a few inches. This is a long clock, and I'll show you a wider camera shot in a minute. So this clock will run more than a week, but the idea here was that if the power is out for even a couple days, this clock can still keep time. I just started working on this clock, and I want to give a pointer to Dave Dietrich, who has a YouTube channel and has a lot of great information on these clocks, the maintenance, overhaul, all that kind of stuff. And because his content is so good, I'm not going to try to duplicate what he's done, but I did want to do a little bit of a look into this particular clock that I have. I wired this up. This does run on 120 volts, and I put in a little inline fuse holder there with a 1/4 amp fuse, which based on my calculation, I think should have been about right for this motor, which is rated at 1/70th of horsepower, which works out to be about 10 watts. And when I tried to wind the clock, it blew that fuse. And so I wanted to just take this apart and check the mechanisms and see, do I just need a bigger fuse within reason, or is there some other issue in the drive line that needs maintenance before I do something that might cause damage to the clock. So that's the point of this video. I have off camera disconnected the motor, power leads right here, and most of the nuts. I'm going to just finish that, and we're going to remove the motor. And see what we see. You can see this is the main drive shaft, and it does feel a little sticky, but I am able to turn it, so it doesn't seem like maybe that's an issue. I do have the weights on, and the way that I can turn it here is actually unwinding. This mechanism here with the black gear, there is a locking mechanism that prevents, if you remove the clock movement, this from just freewheeling away. So we'll take a look at the motor first, and then if that checks out, then we'll go a little deeper into here, and I don't know if I'm just encountering some friction off of a clutch or if we need to oil this, but this is a little sticky. Here is the motor removed from the clock. This is a universal motor. One of the quirks of this is that it can run equally well on both AC and DC volts. This is a brushed motor. There are brushes right here on either side. If we look through the vent holes, you can actually see the commutator there, which is what the brush rubs on. And this motor has two oiling reservoirs right here, and this is supposed to have some kind of synthetic oil in it, and it looks like either this was oil once upon a time or somebody decided to put like a lithium grease in. So that's going to need to be changed out. We'll take a look at that. Also, the first of the worm drives is mounted right to the motor here. And so if we pull off this cover, I've already removed the screws, we can see our worm drive mechanism. If it'll cooperate here. And this is interesting. Somebody put grease, I don't know if they just packed it with grease, or if they thought that the top of the gear needed extra care, but this grease is pretty shot. It's pretty sticky, so we're going to take this apart and clean this out, and with the gear out, then we can assess how freely does the motor spin. I was not satisfied with what I could reach to clean with the motor assembled, so I ended up taking it apart. Here is our one half of our worm gear. The other is the actual rotor of the motor itself. This is in pretty good shape, actually. Whoever worked on this last, in these little oil cups, put in some kind of grease, and the difference between grease and oil, in my definition, is oil migrates and grease stays put. And this is supposed to have oil on the motor bushings and then grease on the gears. So we got rid of all the other slime. This looks reasonably clean. This is what the motor looks like. There's really not a lot to it, just brass bushing there. Here is our stator coil. You can see right in here and here, that's where the brushes go, and then we have the bearing on the end. Brushes are in pretty good shape on this clock, so we're not going to worry about those. Put those right back in. So I'll get this reassembled and then we'll get some power on it and see what happens. I've got this wired up with some basic oil. I don't have any grease in the gearbox there. I have my voltmeter in current mode, and let's plug it in and see what happens. So we can see why the 1/4 amp fuse that I put in blew. The motor running by itself is taking 300 milliamps there, and this doesn't even have any winding load on it. The good news is this runs nice and smooth. It's nice and quiet, so I'm going to go ahead and repack this full of grease, and we'll look at the rest of the drivetrain. I've got the motor reinstalled. I replaced the rubber bumpers that had turned into a rock-hard substance with some new rubber. And we're going to plug it in and see if it'll move. And there it goes. I've got my voltmeter plugged in here too, and let's see what it is pulling. So it looks like we're just under 1/2 amp. And this is moving pretty slowly, but it is doing the job. So I think this is going to be enough for my initial application here, and we'll probably do another video on more operation of the clock in the future. But just wanted to have you ride along with this quick project while we got into the weeds of the winding system. Thanks for watching.